Hello and welcome to the Traffic Light Doctor's final project for Embedded Systems 3350. In this presentation, I will be going over the background for our problem, the planning period, our initial prototype, and our final prototype. So the problem we encountered was a five-way intersection located in Norwalk, Ohio, of the intersection of US 250, Old State Road, and Town Line Road 151. We interviewed a local resident who complained of a dangerous blind spot located on Old State Road and just general difficulty making a left turn off of US 250 into Town Line Road 151. As you can see here, this is a Google Maps image of the intersection, and so after discussing amongst ourselves, we decided to implement a left turn signal from US 250 into Town Line Road 151 and a right turn signal for Old State Road going into 151 due to this blind spot to the right. So our team decided to create a schedule according to the milestone guidelines that the instructor provided us, and we attempted to at least meet up through either Facebook or at school about 2 or so days before each guideline, each milestone. And so to complete this project, we decided we first had to establish our solution and then create a pseudocode for the solution and then translate that into a flowchart. Then we would draw up a circuit diagram and a C-code simulation in order to generate the initial prototype. And with this, we would be able to create a cost analysis for the circuitry of the board required for this system. So as you can see here, this was our preliminary pseudocode. We had two buttons, one to turn on each of the two turn signals that we had implemented. And so this would rely on an if-else system. And so if, say, the right turn lane button for Old State Road was triggered, we would add a right turn signal to the next cycle of the lights. So as you can see here, we translated our pseudocode into a flowchart where we would activate a standard five-way intersection, which would means that without having to press any inputs, the lights would constantly cycle through the five-way intersection. And so then we would read our Old State Road right turn button, and if it was triggered, then we would add the right turn to the next cycle, and we would do the same for the US 250 left turn button. And then we would, on our next cycle, add in each of those turn lanes if those signals were triggered. And once this was completed, we just return back to the start of the flowchart and repeat the process over and over. So this flowchart was then translated into a prototype C code. As you can see here, this is our initializations, and then these were our delays we needed for each of the lights. And then this was our if-else statement system. So if none of the buttons were triggered, it would just go with the else. But if they were triggered, then you'd add a turn signal to the respective streets. This was our initial prototype circuit diagram. It included 5 lights, 2 for each of the main roads, and 1 for Town Line Road 151. It also had 2 switches, one for the left turn lane in US 250 and one for the right turn lane on Old State Road. We initially, in this stage, did not include the SSI or LCD functionality, as we decided we would finalize our street light system before we would add any other functionality to the system. This was our cost analysis. I went on to the internet and looked for the cheapest options available for each of these required components for our system, and I came up with a total of approximately $38.93 for the entire system. So after the preliminary stage, we decided that we would be able to refine the program, and so we switched from an if-else system as seen before to one based on a finite state machine after we performed Lab 5. The finite state machine was then translated into a finite state machine diagram as seen here. Once we completed the traffic light system, we decided to move on to SSI implementation, or serial synchronous interface. This included the use of a Nokia 5110 LCD, and this display would then show the right and left turn signals respectively. This is our final circuit diagram. It included 3 lights, 1 for each of the roads, and 3 push buttons, 1 for each of the road. It also included our implementation of the Nokia 5110 LCD. And this is our supplies we gathered in order to create the circuit. And so this is our final C code. This was created through the refinement of our previous prototype code. This top section is the initialization, and then as you can see here, we implemented the Nokia 5110 through a hex system, and this was also gathered from the provided extra credit lab by the instructor. And so here you can see is our finite state machine that we moved on to instead of the if-else statement system. So you can see we had 8 states, and within that there was 9 different options. And then the second part is a continuation of initializations for each port. We utilize ports D, B, E, and A. And down here and over here are the control systems for the Nokia 5110 LCD. This is our final project with 3 push buttons and 3 light systems, 1 for each of our roads, and the LCD display for the right and left turn signals. And so our project worked through, once it was turned on, the lights would go through a standard cycle for a traffic light system, and the push buttons worked by, if they were triggered and no other button was triggered, then the corresponding traffic light for that road would turn to green earlier in the cycle compared to the standard one we have set. The turn signals for displayed by the LCD board were connected to Old State Road and US 250 respectively. And as you can see here, we implemented the use of the debugger within Keil, which allowed us to show the timing diagram of our system and display the Nokia board within a simulation. So from this project, we learned that pre-planning as a team makes work go far smoother, and we were able to identify real-world problems and create simple solutions from them using embedded systems. We also were able to create our very own finite state machine and implement an SSI system. So in conclusion, our team was able to implement an embedded system in order to solve a real-world issue, and by communicating with residents of the area and research, we were able to create a practical solution for this problem, and we hope that it will be used in the future at our intersection.
And in this first video, you can see our three-way intersection being simulated by three different sets of LEDs. And here's our final prototype of our three-way intersection. One thing to notice that's different is that we now have implemented the Nokia LCD screen. Some issues that we also had is, if you notice, the far left red LED is not working. Another thing to notice that isn't working is the left turn signal is not displaying correctly on the LCD Nokia screen. Finally, based on our inputs in the bottom left of our final prototype, will trigger what road is active.